Welcome back, guys. Welcome to another episode of this magnificent tutorial. I am Mike, your host, and I will be taking you through sending a message from the server to the client today, and also the other way around. Simple stuff. Before I go any further, I keep forgetting about this, but I want to mention that we have a Discord over here. And, okay, that's kind of weird. Person sending 3 times the same message. Okay, so we have the Discord over here. If you have any problem, you can head over to programming help and get some help over there. Hopefully, people are going to be nice and they will be helping you. Most of the time that happens. Sometimes I'm even there and I help out people. And we also have some people that are dedicated for helping over here that they volunteer to actually help you out. So, that is the Discord. If you don't need help and you just want to chill or showcase your project, you can do so over here. Basically, I'm just saying that we are a nice little community and you should really join us. Yeah, that's it. Cool. Today we're sending messages, we're receiving a message. Which one should we do first? Let's actually do client first. Let's send a message from the client to the server. To do so, I will create a simple button, and that's just, you don't even have to do that, we'll delete it eventually. But I just want to have something that's fairly simple to click on and then see a result. So I have this button over here, and I will hook it up to a send message function. So, under client.cs, let's full screen this thing, and I will create a region down here for send requests, for sending messages over to the server. I will also create a public function called send server that will take nothing in parameter right now. For the moment, it won't take anything. Eventually, it will. Right now, I just want to lay down the groundwork for sending a message. So we'll go ahead and do that right here. We're going to start with a byte array, and that's going to be our buffer. Byte array is going to be size of byte size. So if you kind of guessed it, it's the same thing as we're receiving on the other end. So once we receive a message, like right here, the receiving buffer, it's also a byte array of the same size. So once we create it, we have to create it the exact same way. So what we send is basically what we receive. Okay, so having that done, we then have to do a couple of things here. So this is where we hold our data. Now, when you send that data, if you send a string over, if you send a boolean over, it's not going to be a byte array. You'll have to convert it in some sort of way, which we'll see fairly soon. This is where you would crush your data into a byte array. I am going to skip this for now, and instead I'll do something like, okay, so our buffer at the index, say 0, is going to be equal to 1. We'll just set the first byte of our buffer. Our whole message is going to be 1024 bytes. We'll take the first one and we'll just put that one on the 1. It's a byte, so you can put it on 256 if you want, or 255 is the max value, sorry. Yeah, so don't worry about what I'm putting on there. I just want to see if that number is going to be matched on the other end, basically. So this is temporary information. Okay. Once we have our message, now it's time to send it over to the server. And we do so using network transport again. Send, and let's have a look. So it takes in host ID, which is information that we do have in this case. Host ID stays the same whether we are WebGL or not. Connection ID. We also have that. We're only connected to one person. Channel ID. Well, in this case, we only have one channel, right? It's always the same thing. Connection ID is not defined. That's my bad. We'll go back to it in a second. The buffer, so our information. The size, so in this case, buffer.length. Or, as I mentioned earlier, we can use byte size. And finally, out error, in case something goes wrong. So, couple of problems in here. First, the message we send is always the same, and it's kind of useless information. And second, connection ID, who is that exactly? Well, connection ID is actually not inherit, but it's actually being set in the initialize over here. And I haven't done that before, so I have to go back and do it. I wanted to skip it and explain it later, so here it is, private int connection ID. You know how when we connect to our host, we do a .connect. This also returns a int, so we have to do connection ID is equal to that. This is so in the future, if you have like a peer-to-peer game, you can connect to multiple at once, people at once, and other client can also connect to multiple people at once. this connection ID will help you keep track of who is who. Now, of course, I put it here, but I have to put it here as well, because this needs to work for a web. And the thing is, you're not going to have an error until you actually push that on the web, simply because this code does not exist in the mind of the editor. If we're not in the editor, then this code doesn't exist. So just make sure you do your fix here. In case you don't even know if it works or not, make sure you delete everything, all the preprocessor, and you'll see if this compiles. Okay, having this out of the way, let's actually try and send our message and receive it on the other end. So I will quickly just take this button that we've made and I will hook it up to my function. So drag my client in here, client, send server, let's click on play. Servers first, as always, and then the client runs. We have been connected through host 0, and I'm going to click on this. Data. So data, we receive data. What is this data? Let's have a look at this thing. Well, we have a data event. Something happened, and apparently there's something inside of our receiving buffer. So we know the message was sent, but we don't know if the message is the same. So to know this information, you can have a look. You just have to look at the rec buffer. In this case, we only changed the first byte, so let's go ahead and do receiving buffer at the index 0. See if our number is going to be 255. So again, let me quickly just run this over so I can let everybody know that this works and this is safe. 255, our information we sent from this one was sent over to this one successfully. Okay, but this is not cool. Why is this not cool? Because we are not sending anything interesting. We're just sending a single byte, and you know, that's not a string, that's not a player information, that's not his position, that's not anything special, it's just a single byte. We won't be able to create any miracle with a single byte. So what we'll be doing today is we are going to create a data structure, actually a class, that will hold information about messages in general. And then if we want to create a specific message, send my position, send a byte request, we will extend from that class. So without further ado, I have to introduce a concept of shared code. What do I mean by this? Is the following. So we're going to have a folder inside of the client and also inside of the server, and that shared folder, it is going to be the same on both ends, and it also has to stay the same. I will show you in the next episode also how to make sure that is the case, but today we'll do it manually for once. The whole goal of having this shared folder is to have code that matches on both ends. So what we're going to be doing here is we're going to create messages, assuming send position messages, and it's going to be defined in such a way that both persons need to know. So if the client decides to fill in all that message, he sends it over to the server knows how to read it properly. Now, is this the best practice? I am going to say straight away, yes. If you're trying to read and develop on your code and actually just make things work, I think it's a very, very good approach. However, if you have problems when you get bigger, once you achieve a certain level and you have a lot of users, and people try to be malicious and maybe cheat in your game, having the definition of your message on the client makes it so they know what the server wants. So you might have to switch things around once you get to a certain point. But as you're learning and as you're just like understanding how this whole multiplayer thing works and how sending message works, just use a shared folder. Don't worry about hackers just yet. You can worry about hackers in the future. Back to the topic. We have this shared folder. I'm going to right click on it and create a new net message. So I typed it this way, and I'm also going to open it up and we'll have a look at what we can do in here. So everything that's going to be inside of a net message has to be extremely small. Everything that goes in here is going to be put on the road. It's going to be put in a packet. So everything has to be as minimal as possible. Now, here's what I will be doing. I have to make sure that this is serializable, so I'll do a system.serializable on top of this one, because the method we'll be using to send it over and serialize it is going to be a method using binary formatter. This one does a lot of work for us without having us to worry about the order in which we type our stuff. So just to say that clearly, basically, we're going to be using binary formatter in this section, in this tutorial. In the second tutorial, the game one, we are going to be using binary writer and also reader. The reason I'm doing a shift like that is simply because with the binary writer and reader, you have more flexibility, you have more optimization that you can do, you have a couple of more things that you have access to. However, it's not an easy thing to get into as you are starting out. I really recommend that you use binary formatter, and once you're ready, you can easily rewrite your binary formatted class into binary writer and also reader writer. Okay, but as I mentioned, for this tutorial, we'll be using a easier option that is already very, very good. Now, my net message is never going to be used on its own. So this class, I never want to see it anywhere. I only want to see extensions of it. I only want to see a thing that inherits from that message. I don't want to see it by itself. Therefore, I will declare it as abstract, making me unable to do a new net message on its own. I really have to use one of its children in this case. One thing that is sure is that every single message will contain a single byte of information called OP. OP will stand for the following, so operation code. You can type it, the whole thing if you want. Mine's just going to be OP like this. The string size doesn't matter. This one is not getting on the this one's not getting on the bandwidth, so you can have as long as you want. It really doesn't matter if you put long names, as long as you understand yourself, and I think that OP just works fine for me. Now, what is that OP going to be? It is going to be a single number that will let you know what is this message. Is it an authentication request? Is it a buy request? And this will all be defined in a class that I'll put at the top here. Public static class, net OP for net operation code, and here I will start defining a couple of those messages. So public const int, first one being none, best one to start with. In the future, we'll have like stuff like this, so requests, login requests, or stuff like that, equal to 1, and so on. Right now, we don't have these messages. We only have a single message, which is basically nothing, and that's the only one we'll be using for today. Right, so if I go down here, public net message, and I make sure I have a constructor, so when I do a new net message, I can say op is equal to net op.none. This is all the code that will go inside of this class for the rest of the tutorial. The only thing we'll be adding up is different operation code, which, are going to be at the top here. So we won't be touching the net message class any further, but we'll be touching this net op kind of class that I use as an enum, really. Okay, so why did I do this? So when I send message, I know exactly what type of base class I'm sending. Therefore, I can put it right in here, and I can say, okay, so once we send a message, well, when we send a message over to the server, we want this to be a net message. What is this net message? Could be authentication request, could be all of that, because they all inherit from that message. So this is going to work for us. Okay. Now, this is where it gets a little bit tricky. This net message, everything inside of it will have to be serializable. Why exactly? Because we're going to be using the binary formatter, and this one is going to crunch all your fields. So these over here, it's going to crush all of them. Later in the future, you're going to have stuff like, say, public string, name, and so on. So it's going to crush all of that into a byte array. So they have to be serializable, which is why we put this here at the top. So this whole class is serializable, which means that the thing that aren't won't go through. So if you come down here and you do a new vector 3, and you type in position, that's not going to work, unfortunately, because vector 3 is not serializable. Well, the default one isn't. You can create your own version of it that is serializable, but this one isn't. So instead, if you are to declare a position, you're gonna have to do something like this. X, Y, and then Z. And if you're doing 2D, you might as well just do X and Y. Now this is just an example. I'm not actually pushing that through the bandwidth right here, especially not in the base class, but this is just to let you know. Now, I'm going to go ahead and actually start using that binary formatter I was talking about, because this is where I crush my data inside of a byte array, and I'm feeling like I should have a message at the same time, so you guys know what I'm talking about. Yeah, so I'll actually create a message so you guys understand a little bit of what I'm talking about here. I'm going to go under shared again. I will be creating a new message. This one is going to be net underscore create account. It's going to be our first message of the whole tutorial. Now, see how I wrote it? I said net underscore and then the name of my message. That's going to be the case every time I create a message, and that's the format I'll be declaring them into. So as soon as we see net underscore, that's going to be a net message. Therefore, this has to inherit from that message. This also has to be serializable, so system serializable. Won't need any of those at the top. The more I strip, the better. Of course, those are namespace, so they won't be compiled anyway, but here we go. So this is going to be my new message. I will now go back inside of net message by selecting it, pressing F12, and declaring myself a new const int for create account, which is going to be equal to 1. By the way, let me just remove that. Okay. Then, one more step. I'll go back here and implement a constructor for net create account in which I change the operation code to create account. Now we're almost done. We have a message that inherits from that message, so this one is not abstract. This one we can actually use. However, it doesn't have any information in it, which makes it useless. So let's change that. What exactly are we going to need when we create an account? We'll need three things. A string for username. Also a string for password. This will be not hashed, this will be encoded or encrypted eventually, sorry about that. And also email, so username, password, email, those are all information I want to have in my create account message. I don't want to have it in any other message. I don't want to have it in all the message, so that's why they're not in here. I just want to have it for my create account message. Now I feel that since now we have a message, I'll be able to explain to you a little bit better how we go about doing this. So this is where you would crush your data into a byte array. This is where we crush our three strings we have and also our operation code inside of a byte array. How do we go about doing this, you ask? We use binary formatter. It is quite a great tool, so let's go ahead and do binary formatter like so. So highlight this thing, press Ctrl and dot on your keyboard, and you'll see this one is from runtime, serialization, formatter, and then binary. If you don't know what I just did, I included this at the top here. So system, runtime, serialization, and so on. I will declare my formatter right here, and I'll just instantiate a new one. Now our information, before we actually format it, before we write on the packet, on the buffer, on the byte array, we have to create some kind of stream. It's not a file stream. In this case, it's going to be the most efficient one we can use, which is a memory stream. We will be doing it straight from the RAM. So we'll do a memory stream. So this one, I think, is from system.io, if I can recall. Yeah, using system.io. MS, and it's going to be a new memory stream that will use my buffer to initialize. So we have our formatter, and we also have a space of memory with our buffer in it. We'll go ahead and we'll use our formatter to serialize our stream, so MS, with the object. What is the object? It's just message. That's our message. That's all we need for it to work. We don't need to define anything more than that. Why does that work? Because everything inside of message is serializable. So we click on this, we go inside of it, that's a net message. Net message, well, assuming it's a create account, right? Here we are. This is serializable. All of these are strings, simple stuff, serializable. It inherits from this. Everything in here is also serializable. So we don't have any problem here. Everything works. Now you're going to have a problem on this line if you're trying to serialize a vector 3 or anything that isn't serializable. And here we go. We have changed our information, our three strings, our operation code, they're all now in a byte array, which means that we receive a byte array on the other end. We don't receive a create account message, we receive a byte array. So what we'll do over on our server, here it is, in the onData, we now have to receive it in a different manner. Well, basically, we didn't do anything there, so we have to receive it in general. So how do we go about doing this? We do the exact same thing as here, but in a reverse order. So basically, I'm gonna create these two, which is we're gonna get our formatter. Of course, we'll need to include system runtime formatters binary and also system.io. Oops, sorry, not new method. My bad. Here they are at the top. Don't forget about them, very important. And then the buffer for this one is going to be the receiving buffer, so the rec buffer in this case. And then what we had on the client side over here was a serialize. On this end, we are going to use a deserialize, but this information has to be stored somewhere. So let's declare a net message. Oh, right, we don't have net messages yet. Before we go any further, let's quickly transfer the shared folder over to the server as well. So I did a right click, open an Explorer, that's my server folder, and here is going to be my client folder. Have my shared, I will copy and paste it inside of the script folder. This is the last time we do this. In the next episode, I will show you how to make it synchronize all the time. Okay. We can now go back to our server.cs where we receive that information, and as I mentioned, create a new net message. That new net message is going to be equal to formatter.deserialize, and we're deserializing the MS in this case, which stands for memory stream, this thing that's made out of our receiving buffer. Okay, I'm also casting this as a net message here because deserialize will send you an object, but you need to know exactly what type of object this is. In our case, the most basic type we can cast it to is a net message. And from this point on, we would actually do a switch on the operation code to know which message it is, and we'll parse it in different ways depending on what message it is. Now, let me go ahead and do this real quick. We're going to create a function called onData, and the onData is going to send us a couple of information about this message. So, who sent it, in case we need to send something back, which channel did he send it from, which platform is he using, so receiving host ID, and finally the message itself. We are going to create this new function, private void onData, so int CNN ID, int channel ID, and then we'll do host ID here, and finally, actually I'm going to call it receiving host ID, else it will have conflict with the one on the top, and finally a net message. Here it is. I will also create a section for this called onData, for the simple reason that this one's going to get crowded a little bit in the future. So let me just zoom on that. I don't know if my face is in the way. Do an n region, and we can say something like debug.log. We'll put that temporarily, right? So received a message of type, and then I'll just use message.op for operation code. Eventually, we're going to parse it and actually check out which type of message it is. Now, based on what type of message we receive, we're going to take different path, different action. Therefore, we'll have a switch in here on message.op for operation code. This is where we'll start having fun with the case. So case net op. If it's nothing, let's just do a break. If it's create account in this case, then we'll have a specific function just for that. So what I'll be doing throughout this episode, or throughout this tutorial, is that we'll do this like that, and then we'll just create an account with the same exact name as the message, create account in this case, and then we'll send that information over to that. So CNN ID, channel ID, rec host ID, and here is going to differ. Instead of sending the message itself, we're going to send a cast message. So net on create account, create account, and this one's going to be, of course, message. Okay, so that's how it's going to differ. Now, every time you're expecting a message, you'll create a new case for that. Is that the most efficient way to scale up? No, it's the most efficient way to learn right now. In the second part, we'll have a much more efficient way to declare these. In fact, we're not going to be declaring them. It's going to be an event-based system. But right now, as we're learning this and as our application is very small, we'll be using this method. Okay. Again, I've created a new function. It's time to declare it. Private void. Sorry about that. Create account. And CNN ID and channel ID. I actually don't need this information for a create account. Actually, I do need the channel ID, connection ID to send a message back to the user, but I won't need the channel. And I believe I might need the host ID. I think my face is getting in the way here, so I'll just scroll over there. This is basically a create account. I'll just call it CA for create account. Okay, so here I'll do debug.log and just say create account message, and we'll see what this is in a moment. We can also go ahead and, since it's going to be a create account message, we're going to have different information in there, such as, so let's see, 0, 1, and 2. Those are going to be ca.username, ca.password, and then ca.email. We have access to this information in there because it is from create account. Now, I don't want to go deeper than this. I think we are deep enough right now. In fact, I think we actually need to have a look at what's really going on quickly again. We receive a message. That message is going to be type of net create account. This is something that the client will send. Client sends this. He will take care of filling in that information. So username, password, email. We haven't done that just yet. But just assume that we're entering all that information and we're sending it through the send server function from the client. So right here, we're calling this with a net on create account that has information in it. It gets crunched down and then it gets sent to the server. The server receives it over here, decrunch it or deserialize it in this case, and then call the onData with that message. That message is going to go through a switch to know which kind of message it is. If it's a create account, which it will be in this case, we are going to call this. And this will actually just read it out loud in the debug.log. That's all that is going on. Since I'm here, I'm also going to add debug.log for none, say unexpected net OP, just in case like we create a new message and we forget to change the operation code in it. It should not happen, and if it does, it's because we haven't created our message properly. But that's what goes through on the receiving end. We'll have to create that on the server side or client side as well. So I invite you to do the same, and actually what I'll do is I'll just grab this whole onData section. We'll put it above send, I believe, and we'll do the exact same thing here. So the client is never going to receive a create account request, so I'll just remove that completely. And I'll also remove this create account function. We'll just leave it like that right now. He's not expecting to receive any message. We're not sending a create account request to the client. He's not able to create an account. However, we'll be sending a on-create account after we've completed this, because he needs to have a response, some kind of feedback to his request. Okay. That's not all we need to add though. We also need to go inside of the message pump, and over here in the data event we have to make sure that we actually call this onData function. So remember, we have this call over here. Let's grab it, put it here. Stays the same, is the exact same thing. In this case, we don't really have to send connection ID, channel ID, receiving host ID. All of these don't really have to be sent. I'll keep it. I have nothing to lose by keeping it. This is not bandwidth code. This is not server code. This is client code. So in terms of optimization, your priorities are always going to be the same. You're trying to optimize the bandwidth code, so whatever goes through those packets. Then you're trying to optimize the server, so to remove some load off him so he can work faster and actually receive and send those messages faster. And then after that, final thing is you're trying to improve the client to give the client a less laggy experience, but very, very rarely does this occur. This is the priority, and the send is the other priority. and also making sure your net message are not filled with crap over here. So, having this done, let's have a look. Are we missing something? We are missing only one thing. So we have the receiving end and the sending on the client. However, we're never sending anything back to the client from the server. And I wanted to keep this one for last because it's a little bit different. It's not just a copy of that. Well, right now it is, right? So grab this, put it on this end, and then let's have a look. So we're creating our buffer. That's totally fine. We're crunching down our message. That's fine. Yeah, that's actually fine. And then we're sending it over to host ID. Okay, already there. Host ID is only for standalone, so we're missing the web host. And then we're sending it to connection ID. Who's connection ID? We don't know that. So the send server actually become send client. And to send a message to the client, we need to know who we are talking to. So we'll have a int over here called connection ID. We need to know who we're talking to, so we need to have that int. Once we create a message on the server, we call send client, sending it to X client, and then that's the message. Cool, so let's grab the connection ID, put it here. But at this point, what I pointed out earlier, this is only for standalone client. It's not going to work if you are sending this over to a WebGL client. The fact that we might be sending messages over to something else than standalone also has us requiring more information in this parameter. We need to know who is the receiving host in this case. So actually, we don't need to know who's the receiving host. We need to know where the message came from. So we have to send that message back to the right port. And this is why we're also taking the receiving host in here. That's going to let us know whether the receiving host is 0 or 65,000 something. Okay. Well, okay. Assuming that it is 0. So if we get a receiving host that is equal to 0, then we're going to send it this way. Fairly simple. Else, we're going to copy that over and just send it to web host ID. And that's it. That's all we need. Okay. Now it's time for testing. It's a testing phase of the video. We have the receiving end on both client and server. We have the sending on both client and server. Now let's try and send a create account request from the client. What we've done before is not going to work anymore. Simply because our send server takes now a parameter and we can't create that parameter out of thin air by pressing a button. So I will be creating a test function. Like, we'll make it really obvious that this is going to be deleted. I'll say this is a public void test function create account, like whatever. Just put something in all caps. And at this point here, we are going to create our message, which is something we'll be doing most of the time. So net create account, and then we'll do a new. By making it a new instance, this will call the constructor. Constructor will say, hey, my operation code is actually 1 and not 0, like my parents said. My parents said 0, this one is actually going to be 1. And from here, we'll gather the information we need from the client in whatever fashion we want, and we'll make sure to set it. So username can be swag, and the password will be bamboos. And then the email will be something. Then with that message, we can call send server with that message. And there we go. That'll work if we have the right syntax. Let's try this out. We're going to close everything. Well, not close everything. We're going to make sure everything is minimized. Now I will take my button, hook it on the new function we've created, the test function. So test function create account, boot the server first, then the client. Let's have a look. Opening port, attempting to connect, connected through 0, and we have connected to the server. Let's click on this button, and we see swag, bamboos, and then the email over here because we entered the create account. So we've been routed properly. And that's how we create messages. Okay. That is actually the hardest part of the tutorial is actually behind us thus far. We already made it to a point where you should have a okay understanding of the thing. You still have to practice. You haven't practiced yet, and you haven't sent a message from the server to the client just yet. But you should have at least the minimum understanding required to send a message over in the fashion you want in a scalable manner, but not a infinitely scalable manner. With this technique, at least you're not writing strings and having pipe in between them like we've done like 1 year ago. That was disgusting. You're much more efficient right now. You're actually using a binary formatter. You are serializing your data before you send it over, so your bandwidth is fine. Of course, the only problem right here is that if you end up having a lot of messages that you need to receive, this switch case right here can go on for a while on both ends, so on the client and also on the server. Not a problem in the second part. For learning purpose, we'll keep it that way in the first part. That's it for now. Alright, so in the next episode, we're going to take a small break. We're going to be doing a lot of UI for the client side. We're going to be sending a create account request, a login request, and we're also going to have some client side feedback. So expect to not do much learning in the next episode, but at least implement some stuff a little bit better. And then once we're done with that, we're going to go and move on to the database. Okay guys, thank you so much for watching. If you made it that far, tap yourself in the back. The hardest is behind us. So I'll catch you guys in the next one. Cheers.